Monday. So we got a couple more sections to finish up for the exam. So let's keep going then with what we talked about on Friday with average rate of change. And then we'll get into new stuff with linear functions. All right, so remember last time we talked about how we find average change of a function. And just to remind, so if I want to know the average change of a function on an interval, say the interval from A to B, how do we do that? What do we do to figure out the average change of a function on the interval from A to B? Good. Yep. You do f of b minus f of a over b minus a. So again, we look at the net change in the function, ending point minus the starting point, right? Ending y value minus the starting y value. And then divide by how long it took, the length of the interval, b minus a. Your ending x minus your beginning x. Okay. We related that last time to slope of a line, right? It gives us a slope of a line between 2 points. We're going to go back to that here in a little bit when we go talk about linear functions. The last thing we did on Friday, right before we took the quiz, was the idea of the difference quotient, and that definition's up here. I'll rewrite it down up here a little bit bigger. So when you do your difference quotient, you do f of a plus h minus f of a all over h. That's the average change on the interval from a to a plus h, and that's what this picture over here was, right? We started in a, we move a little bit. H could also be negative, but we move from a just a little bit. That's what the h is representing. So to get that expression for the difference quotient, you do the difference of your y values, f of a plus h minus f of a, over the difference of your x values, the a plus h minus the a. When you simplify the denominator, you just get an h. And remember, we need to make sure that that h is not 0 because we can't divide by 0. Okay. So let's just do a couple of examples here of computing the difference quotient. We compute it the same way every time. We just need to remember that, this notation doesn't mean take the function and add h to it. What does that notation mean? When we put in something in the parentheses here. What do we do with this? What's in the parentheses here? What do we do if it's a number or a letter or an emoji? Substitute it where? For x, right? This whole thing goes in for x. Do not write down f of x and then put a plus h on the end. Okay? If you do that, every single problem will turn out to be 1. If you're getting 1 every single time, you're doing the substitution wrong. Okay? This does not mean take the function and put a plus h at the end. Okay? Not what that means. You have to take out the x and put an a plus h for the x. Okay. So in this particular example, we have 5 times a plus h minus 3. Took out the x, put in the a plus h. That's f of a plus h minus, we put in the a for x, we just get 5a minus 3. Then all over h. Distribute the 5 through, we'll get 5a plus 5h minus 3. Distribute the minus through, we'll get minus 5a plus 3. what happens in the numerator? Good, the 5a's cancel out, and so do the 3's, right? And the only thing we're left with is 5h over h. And then what can we do? Yeah, the h's cancel and you get just a 5, right? We do need to make sure that that h is not equal to 0 when you do that cancellation. Because again, we cannot plug 0 in for h. So that cancellation is not valid if h is 0. But if h is not 0, then we can cancel it just fine. By the way, this is your goal in all of these problems, is to try to simplify it to kill the h in the denominator. That literally is the whole point of this exercise, is to try to get rid of this h in the denominator. It comes up in calculus quite a bit, so that's why we were doing it here. But that's the whole goal of this, is to try to get the h out of the denominator. However we managed to do that. No, do you notice anything here again between this 5 and the function we started with? What kind of if I replace the f of x with y, what kind of function do we have? See? Yeah, it's the slope-intercept form of a line, right? And what is that 5? It's the slope, right? And again, we talked about that last time, that your change in your function, your average rate of change in a function for a linear function is its slope. So it's not a huge surprise that we got the slope out of here. Let's do another 1 or 2 or 3 of these. Make sure we're all on the same page. Okay. The next one also says to do f of a plus h minus f of a over h. Find the difference quotient. What do you get when you put in a plus h for x in this case? 1 over a plus h. Good. And when you put in a for x, you get 1 over a. All over h. Now again, I just told you a little bit ago that our whole goal here is to try to cancel the h out of the denominator. Kill the h. Okay? That's our whole goal. Can I do that yet? No. So there must be some sort of algebra thing that we can do to be able to help us kill the h in the denominator. Now notice, last time everything canceled out and we had just an h left on top, right? This one, we don't have a lot of simplifying we can do right away, but it would be nice to be able to rewrite what's up here in the numerator. What can I do to rewrite what's in the numerator? What can I do to combine those two things together?
You could cross multiply so that you can get the same denominator on the numerator side.
Okay. Yeah, so you want to get a common denominator is what you're telling me? Okay, cool. Yeah, so notice that this has a plus h in it, this has a in it. To be able to combine them, we need to have the same numerator. Or, excuse me, the same denominator, right? So what do we need to multiply the first fraction by to get the common denominator here? Now, I need to multiply by 1, but what special form of 1 do I need? If I have this in my denominator, I need to have an a plus h in the denominator, so it'll have to be in there. I have an a in this denominator, so it'll have to be in there as well, right? So what is the common denominator going to be? Let's start there. Okay, let me ask a simpler question. What's your common denominator? 6. How did you come up with 6?
Multiply them.
Yeah, multiply them together, right? I need a 2 here and I need a 3 for both. I need a 2 for both and a 3 for both, right? Yeah, go ahead.
So you need to multiply a plus h and a.
Yeah. Okay, so what do you want? So you want to multiply this one by what now? I'm sorry.
A plus h and then a.
So I need an a on that one, right? Yeah. So I need an a times a plus h, right? So what do I need to multiply the whole fraction by to make sure that we keep everything equal? Well, okay. To get the common, let's look over the easy example, and then we'll go back into the harder. To get, you just told me the common denominator here was 6. What do you multiply the first fraction by? Be 3 over 3, right? And the second one is 2 over 2, right? You're multiplying the one fraction by the missing part, right? This one's missing a 3, so I multiplied it by the 3. I got to do the same thing on the top, right? Over here, this has a 3. I'm missing a 2, so I have to do the same thing on the top. Apply that same principle over here. What do I need to multiply top and bottom of this one by? A, because that's missing, right? So for the other one, what do I need to multiply top and bottom by? A plus H. Good. So let me rewrite it this way. So the first fraction I multiply by A over A. The second fraction we multiply by A plus H over A. A plus H over A plus H. Still all over H. What do you get now when you combine the two fractions?
H over A times A plus H.
Okay, gonna be a little bit careful. You're close. Minus sign's gonna get distributed to both. It's negative H. Good. Yeah. Don't forget subtraction here. So this minus sign is going to get distributed to each term in the numerator on the second one. So I get A minus A is 0, but I still have a negative H there. All over H. Okay. Everybody okay with combining those two? Now I still need to simplify. I'm dividing this fraction by H, or think about it as divide by H over 1. When you divide, it's the same thing as doing what? By the reciprocal, right? So I can think of that the numerator minus A over A plus H being multiplied by the 1 over H, because I'm dividing by H over 1. From multiplying by the reciprocal, and now what do you get? What happens now? Let's look at this. What happens now? Yeah, those will cancel each other again, right? The H's will cancel again, won't they? That's a 1, that's a 1. So you get negative 1 over A times A plus H. And again, this is true if H is not 0. Either way, it means the same thing. You can put the negative on the top or the negative out in front. It'll mean the same thing in this case, since there's only one term. Ordinarily, we would write it all the way out in front, but it doesn't matter if you put it in the numerator or not. Work on the next one for a minute, and then we'll chat about it. And then we'll do the last one together. Oops. All right, next one. Ready to chat about it? Yeah. Oh, maybe. Yeah. All right. So it's asking for the difference quotient. So what do we compute again for difference quotient? Good. I do f of a plus h minus f of a all over h. This is one of those types of problems that you should never ask, how do I start? That's how you start. Every single one of them. Okay? So if you see a problem that says difference quotient, that's what you want to do. Okay? So you should never ask the question, how do I start this problem? That's how you start this problem. Okay? All right. So again, what does this a plus h part, or f of a plus h part tell you to do? Yeah. Substitute the a plus h in for the x, right? So what do you get when you substitute that in for the x? Okay. Good. Right. We're just taking out the x, replacing it with a plus h. So we get a plus h quantity squared plus 2 times a plus h minus 3. The other part is what? Good. A squared plus 2a minus 3, and this is still all over h. So far, so good? Okay. Again, I told you what's the goal of all these problems. What do we want to do at the very, very end? Yeah, simplify it and cancel out that h, right? The h needs to go away. That should be your very last step in these, is cancel out the h. Okay? So what do we need to do before we get to that point? What do you think? Yeah, distribute everything out on top, right? Multiply everything out. When you multiply out your a squared, or excuse me, your a times, try that again, a plus h squared, what do you get? Good. Don't forget to FOIL, right? Don't forget to do all your distributions. You get a squared plus 2ah plus a squared h squared. Right? Got to do all your multiplications. Distribute your 2 through. You get 2a plus 2h. And then minus 3 on the end. What do you get for the second part?
It's just negative.
Yeah, it's negative a squared minus 2a plus 3. Don't forget to make sure that minus sign applies to absolutely everything in that second one. Now, again, your whole goal, again, I told you the very, very last step we want to do is remove the h, right? In order to be able to remove the h, we're going to need to factor out an h on top, right? Right now, I can't cancel an h with anything. I don't have a product, right? Right? In order to be able to cancel top and bottom, in order to be able to divide out on top and bottom, it has to be a product. You cannot cancel individual terms. Okay? You cannot. This h, for example, I can't cancel the h without h squared. I can't do it. It's an individual term. It's not a product. Okay? It has to be products. In order to get a product, I need to factor out an h. So that means that anything that does not have an h in it needs to go away. I'm going to be able to factor it out. Does everything that doesn't have an h in it go away? Well, here I look at this first term, a squared. Does it go away? Yeah, because there's a minus a squared over here, right? How about this one? There's a 2a. Yep, that one also goes away. There's a minus 2a over there. How about this one? That doesn't have an h in it. Yeah, it cancels with a plus 3. Okay. Absolutely everything that did not have an h needs to go away. So we have 2ah plus h squared plus 2h all over h. Can I factor out an h now? Yeah, what are you left with after you factor out an h? Good. 2a plus h plus 2 all over h. And this gets us to where we were trying to get to, right? This gets us to the promised land. We were trying to cancel out the h. Can I do it now? Yeah. So we get 2a plus h plus 2, and again, provided your h is not 0. Questions on that one? All right, well, let's do the last one together here. Again, asking us to find the difference quotient. They called the function in this one j rather than f, but it's the same formula. We'll have j of a plus h minus j of a all over h. Exact same formula. Doesn't matter what the name of the function is. What do we get when we replace a plus h for x? Good. And then minus what? Good. So we have the first part here. I got to get rid of the x. I'm sorry. Take out the x, put in a plus h. Second part, I take out the x and just put it in a. Again, entire goal of these problems, get rid of the h in the denominator. Okay? It's the entire goal of these problems. Can I get rid of the h right now? No. So I need to do something algebraically to get rid of that h. You might be tempted to try to square top and bottom. There's two reasons why that's not going to work. One, when you square a fraction, it doesn't stay the same. Right? If I square top and bottom of a fraction, it doesn't stay the same. You have to keep everything the same, right? The second part is, if I square the top, I still don't get rid of the radical. Because you still have to multiply everything out using FOIL, using distribution, and you'll still have a radical left. Okay. So trying to square this isn't going to work. But the idea of being able to square radicals is. Okay. So let me remind you a little bit. If you want to factor x squared minus y squared, how does that factor? That's a special form. Should know that one without even having to think about it. So what? What do we call that? What's this thing in the middle? Not a trick question. What's this thing in the middle? The subtraction. What's another name for the subtraction? Okay, negative. What's another name? If you want it, difference. It's a difference of squares. How does a difference of squares always factor? You had something like x squared minus 4. How would that factor? Okay, yeah, right. That's how x squared minus 4 factors, right? Difference of squares. So this one with x squared minus y squared, how's it going to factor? Cool. X minus y, x plus y. Good. That's one that you shouldn't have to think about if you've got a difference of squares. That's one's a pretty quick one. Okay? All right. Why do I care about this factoring? Well, notice if I square that term and I square that term individually, what happens to the radicals? They go away, right? Agreed? Yeah, all right. Notice over here, I've got this minus this, right? Well, if I do x minus y and multiply it by x plus y, I get squares in individual terms. So what do you think I might want to multiply this numerator by to get rid of the radicals? Here's, right in red, here's x minus y. If I want to make it x squared minus y squared. Yeah, multiply by a plus h minus 3 plus a minus 3. That gives me x plus y, right? This is my x, this is my y. X minus y times x plus y is x squared minus y squared. Now, can I just multiply the top by that and keep everything the same? No. And I multiply the bottom by it too. Okay. Now, do I want to multiply out the bottom? Remember again, what are we trying? What's our ultimate goal with these problems? Get rid of the h. Do I want to multiply out the bottom then? No, I want to leave the h factored out. Don't ever multiply that h through. It's not going to help you. You're just going to have to refactor it back out again to get it to go away. Okay. Now we've rigged this so that the top simplifies to something very specific. We multiplied x minus y times x plus y to get x squared minus y squared. So what do we get on top? What happens to the radicals here? They go away because we squared them, right? So it'll be a plus h minus 3 minus a minus 3. Don't forget your parentheses. That minus sign applies to the whole second part. What do you get on top now when you simplify? Just an h, right? You get a minus a, those cancel. You get negative 3 minus a minus 3, those cancel. You should get h over h times square root of a plus h minus 3, a minus 3. And now we're at the promised land. What can we do now? Cancel the h's. Good. We get 1 over square root of a plus h minus 3 plus square root of a minus 3. When we flip the sign in the middle, there's a special name for that. What do we call these two pairs? We have this minus this and this plus this. There's a special name for that. What do we call the pair of those expressions? Do you remember? If you had like something like 1 plus square root of 3 and 1 minus square root of 3, that has a special name. Say it again. So that is, I think this has something to do with perpendicular lines when you're doing the opposite reciprocal, which we'll do here in a minute. I'll go ahead and tell you. These are called conjugates. Conjugates are going to pop back up again later on in the semester. The conjugate idea, the conjugate pairs come up from this concept. When I do x minus y times x plus y, it squares the individual pieces. It makes it a difference of squares. All right. In any event, are there questions about that one in particular? The idea of being able to multiply by a conjugate is an important concept that pops up several times in math classes. So it's going to be something that will pop up again. And probably again. All right. Let's go on to the next section then, where we talk about linear functions. We've already mentioned linear functions a little bit. When we talk about a linear function, the whole point is that we know lots and lots of information about that particular function. So when we talk about a linear function, what its form is, it's probably a form you're already used to. It was even mentioned earlier today. Usually, We write it as AX plus B. You probably think about it as MX plus B. It's that slope-intercept form, right? Here's the important part for being linear. The word linear means that when I see the variable, the only possibility I have for that variable is raised to the first power. It's not squared, it's not cubed, it's not square rooted, it's not inside another function, it's not divided. It's literally just constant times x plus another constant. That's the form of a linear function for us. Okay? Now, like I said, given the fact that we have a linear function, that tells us lots of information. In particular, when you hear the word linear function, what's its graph going to be? A line, right? So the graph of a linear function is a line, but even more so, when it's written like this, you also know things like its slope and its y-intercept. What is its slope, in this case, when it's written like this? And the A. And what's the y-intercept? B. Technically, y-intercept is a point, so I should write it as 0, comma b. All right. So this is the point. Points are described with ordered pairs. All right, so this is a familiar function that you're used to, right? You're used to linear functions. You probably just call them lines to start with. If you want to put it in y equals mx plus b forms, because that tells you what the slope is, what the y-intercept is, it allows you to get the graph, lots of other information, right? So the whole reason why we want to put it in this form first. We just finished up the section on average rate of change, and we already talked about this. How does the average rate of change for a linear function relate to some piece of that linear function? What is the average rate of change equal to? It's the slope, right? So the average rate of change of a linear function on any interval, doesn't matter what the interval is equal to the slope of the line. No matter what interval we're talking about, if you look at the average rate of change of the linear function over that interval, it's always equal to the slope. It's always that constant. Okay. So a linear function in particular has a constant rate of change. It's a very specific property of being a linear function. The rate of change is constant. All right. So part of what we want to do in this particular section is play around with finding different linear functions given properties and do some modeling with some linear functions, solving some word problems. That's what we mean by that. So let's just see if we can answer some questions about some of these problems here that I have written down. This one asks for a linear function with the following properties. It says that when you plug in 0, you get out -9, and the slope is -8. Well, that slope being -8 tells you which of the values that you have for the a or the b. Which of the values do you have if you know the slope is -8? The a, right? The a is the slope value, right? Okay. So I know right away that a is the -8 piece. What does this first piece of information tell you? It says if I put in 0, I get out -9. What information does that give you? It's the y-intercept, right? When you put in x equal to 0, you get out -9, which means what point must be on the graph? If I put in an x and get out a y, what point has to be on there? Yeah, 0, -9 has to be on there, right? Remember, that's what it means for a function, isn't it? When I put in this value, I get out that value. When you talk about the graph, then 0, -9 in this particular case is on the graph. Well, if it has an x-coordinate of 0, it's on the it's on the y-axis, so this has to be the y-intercept. So what does that tell you as far as the form of the function goes? What does that tell you in here? You told me the a was -8 for the slope. The b is negative 9, right? So your function here will be what? Negative 8x minus 9. Good. So this particular one told us explicitly what the slope is and explicitly what the y-intercept is, and we were able to plug those right in. Generally speaking, that's exactly what we're going to look for in any particular function, or sorry, any particular problem. We're going to want to know what is the slope, what is the y-intercept. We can just plug it in, that gives us the function. Okay? Now, they don't all tell you explicitly what they are. Sometimes you have to go figure it out. Okay? So this one asks us to find the linear function that has those properties. One of them is pretty much explicitly given to you. Of the two numbers that you need, the slope and the intercept, which one is given to you explicitly? Yeah, the 0, -4. It gives you the y-intercept, right? This point right here gives you the y-intercept, right? So then you put it in 0, you get -4. So the other piece of information we need is what? The slope, right? You agree with that? Okay. So one of the ways that we can figure out the slope, and you probably already know how to do this, but let's tie it to things that we've already talked about. Let's tie it to average rate of change. Because we know for linear functions, average rate of change is the slope, right? So if I asked you for this one, what's the average rate of change on the interval -7 to 0? What if I asked you that question based on those function values? Not even worried about whether or not it's a linear function. Literally, if I give you f of 0 is -4 and f of -7 is 7, what would be the average rate of change? How would you compute it? Don't worry about the problem at all. How would we compute average rate of change? What did you tell me before? Yes, f of b minus f of a over b minus a. But what's playing the b and the a roles here? Yeah, 0 is the b, -7 is the a, right? We agree? F of 0 is -4. F of -7 is 7. So we get -4 minus 7 over 7 gives us not the nicest fraction in the world, but -11/7. That will be our average rate of change. Like I said, I'm just trying to tie this back to the stuff that we talked about before. This is how you calculate average rate of change, right? Now, why did I care about it in this problem? For linear functions, the average rate of change is the slope, right? What did we calculate? This expression tells us change in y. This expression tells us change in x, right? So we have change in y over change in x, which is what your slope formula is, isn't it? Right? So that gives us the slope. And again, that's your a value. So now we have the y-intercept and the slope. What would you tell us that the function is equal to then? Good. -11 over 7x minus 4, that's your slope. That's your y-intercept again. I don't expect that you're going to write average rate of change on this interval on here. I'm going to expect that you're going to calculate change in y over change in x. Right? This is what I'm going to expect you to do. But I just want to make sure that we're all tying this back to the idea of average rate of change and slope are the same thing for linear functions. Questions on that one? All right. Let's look at the next couple here. The first problem asks you to express this equation as a linear function. So again, your linear function has this form, f of x equals ax plus b. Graphically, what do we equate with f of x? What do we equate with the outputs of the function? Is the y value, right? So really this means that you want to write it in the form y equals ax plus b. So what do you think you want to do with that equation? Yeah, y by itself. Exactly. That's what you want to do, all right? So we have 5y minus 10 equals negative 3 times 5 minus 2x. What might we want to do? Yeah, distribute the negative 3. Sure. Negative 15 plus 6x. Good. Add the 10 to both sides. When we add 10 to both sides, we get negative 5 plus 6x. Divide everything by 5. So we have y equals, I'll flip-flop it, and they get 6/5 x minus 1. Right, I can split this up. I can do negative 5 over 5 as negative 1, and then I've got 6/5 x. And I just flip-flop the order. So this is, I'll just write it as f of x, just so that we can go back to that original idea. This is when the problem asks you to express it as a linear function, it really just means solve for the y. Okay. And we're equating the y with the f of x piece. It's just a fancy way to say solve for y. Okay. All right. Let's answer the second question here, where it says find a linear function whose graph passes through the point 14,3 and is parallel to the given line. So again, if you want to figure out the equation of a line, you need a point and a slope. Let's concentrate on the slope first. The word here, parallel, tells us about slope. What do we know about two lines that are parallel to each other with regard to their slope? They're the same, right? Yeah, so the lines don't intersect, so their slopes have to be the same, right? If one changes at a different rate of the other one, they're going to cross at some point, right? Okay. So this tells us that the slope of the line that we're interested in is 6 over 5. Because it's the same. So just write that down. Parallel means same slope. Oops. The other piece of information that we need is a point always. Now I could put it into the function and solve, and that's a perfectly good way to do that. But just to remind, there is also something that's referred to as the point slope form of a line. If I'm given the slope, m, and I'm given a point x1, y1, I can write the form of the line this way, and then I can simplify. Notice that all this is just a restatement of slope is rise over run. If you divide by x minus x1, you just get slope, don't you? You get change in y over change in x. Okay. So in this case, in this problem, your m is 6/5. Your x1 is 14, and your y1 is 3. So there's an equation of the line right away, right? Y minus 3 equals 6/5 times x minus 14. That's an equation of the line. If you want to put it in linear function form, what are we going to do? If you want to write it in the formula we have for linear functions, we're going to solve for y again, right? Got to play with the fractions a little bit. I got to distribute the 6/5. 6 times 14 is 84. And then add your 3 to both sides. 3 is 15 over 5. So what do you get? 69 over 5 when you're done. When it says find the linear function, it typically means solve for y. Like I said, the fractions aren't the best in the world, but that's what we get when we solve. Any questions on that one at all? Right. We'll play more with linear functions next time, including doing some modeling with them, and then we'll also start the next section. So don't forget, test next Monday. All right, so we'll talk a little bit more about that as we get closer, but have a good one. We'll see you on Wednesday.